Hello, this is Margot Miranova analyzing the chosen problem of Taylor-Atkins. Taylor's problem was 3.51 in the textbook. After reading the problem statement, she proceeded to draw a diagram and write out her list of givens. From there, she made some system assumptions, including that the heat flow was one-dimensional, that there was no energy generated, and that there was no convectional heat transfer. After making these assumptions, she proceeded to model the system using a series of resistors. From there, she defined each resistor as what they are through their variables as well as through their numbers. She proceeded to plug all of the resistors together to find the total resistance of the system and plug that resistance into the heat transfer of the system from T1 to T2, concluding to an answer of 142.2 watts. Part B, which asked for the temperature drop of the two surfaces, or between the two surfaces, she appeared to use the same equation as she did for the overall heat transfer, which is possible and can be done as the heat transfer throughout the entire system is similar to the heat transfer throughout a portion of the system. However, the resistance encountered throughout that heat portion transfer, or the temperature drop specified in Part B, only goes through the contact resistance between the two surfaces. From there, she rearranged the equation to show that the temperature drop results in the multiplication of the two variables and concluded to an answer of 6.4 degrees Celsius after plugging things in. Overall, Taylor and I took very similar approaches in how we solved this problem. However, the biggest difference is how we modeled the system. After reading the problem statement, I interpreted the system to be two rods stacked together rather than pinched together through a sleeve. That being said, both of us arrived to the same conclusions and the similar answers for both Part A and Part B, which goes to show that the resistance network that we calculated and the resistance network that we depicted for the system was correct. And as the model of the system was correct, the overall diagram, while it differed, did not lead to any discrepancies in our work.